Position vectors. So a position vector of some point P is related to the origin. So we fix, it's a fixed vector and not a vector that goes anywhere. This is bolded, but you might have an arrow over that P as well. Now, you have 2 points M and N. And what the position vector does is it says, I have a position vector M, which goes from O to M, and a position vector N, which goes from O to N. If I wanted to go from M to N, how could I do that only using its position vectors? In other words, how could you write M to N in terms of M's and N? So we want to start here. You want to start here, end here. But you're only allowed to travel along the M's and the N's. So does this make sense as a way to get there? You want to go minus M first, and then you would need to go plus N next. And that would do the same thing as going from M to N.
So little m is the whole line? Little m is from O to M.
Little m is from O to M. Okay?
Because you're not able to travel there from M to N.
I think the uppercase, because then like the ones in the middle cancel each other out, and then it all like, it's visually easier. With vectors, I rate everything.
So you would prefer to write MO plus ON.
Because then you can smash this together.
Yeah.
And make, and then we can just put these.
I like that verb.
I'm going to take this right here and take a picture of it for us.
Demonstrate again.
Okay. Write an M in terms it'll be a negative N plus an M. This time we're starting from N and going to M. That's our resultant. So in order to do that using only N and M, we would go negative N plus M. Now we're going to add P to be the midpoint of M and N. And you want to get from O to P. But you're only allowed to travel in the directions of M and N. How do you do that? Half of each vector. So how does that work? Okay? Does it make sense that you could get from O to P by going from O to M and then going halfway from M to N? Now, this isn't in terms of M and N yet, but at this point we can say, well, I know that O to M is M. And I already figured out earlier that M to N was minus M plus N. I can distribute that 1/2 through, and we'll end up with M minus a half of M, which will be a half M plus a half N. If I distribute this and this, that'll give me minus a half. And if I have 1m minus a half m, I will get half m. So now if I look at that, if I imagine going midway from here to here, and midway from here to here, and taking that green one and adding it on, sure enough, it ends up perfectly at P. Starts at O, ends at P. Okay? Oh, go back? Yeah. We're good to go. The points A, B, and C have position vectors A, B, and C. The point P is the midpoint of AB, and the point Q is the midpoint of BC. Find the position vectors of P and Q in terms of A, B, and C. So again, what we can do is we want to figure out O to P. And the position vector from O to P, we look, well, how could I get there? I could get from O to P by first going from O to A, and then going halfway from A to B. That would start at O and end at P. Now, in terms of A, B, and C, I already know that OA is the vector A. Plus half. How can I get from A to B using only A, B's, and C's? Well, I could go negative A plus B. And simplifying this out, it becomes 1/2 A plus 1/2 B. Similarly, can you see that OQ, if I did the same thing, will be 1/2 B plus 1/2 C. And with this, we can now figure out how to go from P to Q, that vector, but only traveling in the directions of A, B, and C. Which is kind of, when you look at it, really abstract. How would you do that? I want to get from P to Q. I'm only allowed to travel in the directions of A, B, and C. Well, to get to PQ, can you see that I could go from P to O and O to Q? Pook. And P to O is just the negative of O to P, and we already figured out O to P was 1/2 A plus 1/2 B. And O to Q, we figured that out to be 1/2 B plus 1/2 C. Simplifying this, can you see that your B's are going to cancel out altogether? And you'll be left with 1/2 C minus 1/2 A. Now going back to our diagram, going back to our notes, Good? Almost? Yes? Good. So 1/2 c, if I draw a 1/2 c here, and I draw a 1/2 a, a negative 1/2 a, if I drag this vector starting at P, and this one, it works out perfectly to go from P to Q. It's useful for that, eh? For visuals.
What could you have gone the other way where we had?
I could have done, had I written it as negative 1/2 c first,
You've done that? Okay, that's what I was thinking.
plus 1/2, I mean negative 1/2 a first plus 1/2 c, it still is the same thing. And that allows us to say I could have written this either way.
Oh, I see. But
Okay, I could have written it negative 1/2 a first plus 1/2 c.
Well, I think it's the same. I see that.
Yeah. But it's kind of fascinating how the vectors explain how you can use different directions to get from one place to the next, where originally looking at the vector from P to Q would make you think it doesn't really have anything to do with A's, B's, and C's.
You open your lines.
Point O is at the center of a regular hexagon. Given that OA is A and AB is B, find OB. Are you okay with going A plus B? B was going from B to D. How do you want to go from B to D? Okay? You could go BC and then CD. Can you see that BC, I'll write it out, BC plus CD, so if that's the route you take, can you see that BC is negative A? And CD and CD is a negative OB. And OB we figured out to be A plus B. And so we could get it by B minus, negative B, thank you, distribute that, minus 2A's. So when I write my answer that way, this is what you want to say. I could have gone negative B, negative 2A's. And that matches up with our answer. What's the use of this? Okay, I will take, I think, we'll pull out this year's Euclid, and I'll show you how you could have solved a question using vectors on this year's Euclid.
Sure. What's the Euclid math contest?
The Euclid math contest.
Sure, show us.
Okay?
I can't remember.
Was it the Euclid or was it the Fermat? I'll check. I'll see if I can find it. Okay?
What is math contest?
There was nothing that was vectors, but you could have used vectors to solve it.
I think 10. Was it
Okay.
number 10? Yeah. I don't remember. Okay. Jared.
Oh, and then the last one, BD, was C to F.
A.
To go from C to F, if you know some properties of hexagons, that these all make little equilateral triangles, maybe you can see that this is a negative b and another negative b, and do that right away. Or you could take a longer route to get there. But either way, you will get a negative 2b as a result. Just as a thought process for proportions here on this one, before you try it on your own, if AB to BP is 2 to 1, okay? What that means that this length would be 2 and this length would be 1, or any multiple of that. But going from A to B would be 2/3 of the way from A to P. And going from A to P would be 3/2 or 1.5 times A to B. Going from A to B would be 2/3 of going from A to P, right? And going from A to P would be 3/2 or 1.5 times going from A to B. So there are the answers for the first 4.
You probably did your ratios wrong for the last one.
Which one are you looking at?
Last one, because I got 3 over. I thought it was
From O to Q?
from O to Q. The only thing I have is Q.
So O to Q would be going from O to B and B to Q. And O to B, if we look back, our O to B is B. And B to Q is negative 3/4 of A. Because of the ratio, right? B to C is parallel to A to O. And because the ratio says that CQ to QB is 1 to 3, then B to Q is 3/4 of B to C.
I didn't read that. That makes sense. Thank you.
Ratios.
That's important. Without it, you'll die.
And then part B, show that Q to P is 1/4 A plus 1/2 B.
Why didn't you think of looking at that?
Oh, there's the part B.
There's a part B. Yes.
So why do they just not pick one?
Because just for the front to be honest, it never came up on any questions or the exam at all. They just said like
It's done in the past.